So I can't sleep, and so lucky you, I'm going to talk to you about adenosine, caffeine, and receptor sites, and how they relate to each other, and how they relate to you and me especially, and what we call caffeine naps. So if you just indulge me a little bit in my arts and crafts project that I've developed to help show you this, I think by the end of this video you should at least have some sort of understanding as to what I'm talking about. Okay, so let's get with it. Alright, so all of our cells have receptor sites, and receptor sites are specifically shaped to match certain chemicals within the body. So receptor sites for adrenaline are different than receptor sites for things like allergens and other, just work with me on this, basic chemicals within the body. So we have these receptor sites that are specifically formed for that. Today we're going to talk about the receptor sites for adenosine as well as the receptor site for caffeine. And adenosine is a nice chemical that's made in your brain. And one of the things that it does is that when it binds to these specific receptor sites, it induces sleepiness. So if your body gets fatigued, when your body gets fatigued, the little part of your brain sends out this chemical that says release adenosine into the body and make this person sleepy. So the adenosine binds to the receptor site and your body gets sleepy. So here we have adenosine floating through the bloodstream looking for a receptor site, and it finds one. It binds to the receptor site, and this is happening all over your body, and the body becomes saturated with adenosine, and it says, I'm going to sleep. So when you sleep, the adenosine gets released by the receptor sites, so you're no longer tired. It goes back into circulation, gets destroyed, and ends up, coming out your body as some sort of metabolic waste. So what also happens with our friend caffeine, who we met earlier, caffeine looks very similar chemically, at least in terms of the receptor site, to adenosine. So do you see what's going to happen here? Caffeine enters your body in your bloodstream, and it comes in and it binds to these same receptor sites. So now your body gets tired, and adenosine comes along looking for a place to say, hey, Gene, go to sleep. And adenosine can't bind because its receptor site is already occupied by caffeine. So it just keeps going, and you don't get tired. Makes sense, right? So caffeine eventually wears off, and it gets floated off into your bloodstream as well, leaving the receptor site open. So what's important to note about this new discovery with the caffeine nap is that caffeine, once it enters your bloodstream, once it enters your body, it takes about 20 minutes to enter your bloodstream and become bioavailable to the receptor sites. That is, that it can be used for the receptor sites. It takes 20 minutes for that to happen. So as you're getting sleepy, and these little receptor sites start to fill up with adenosine, you drink the caffeine, and it goes floating. It's floating around your bloodstream. It's just kind of not doing anything because it's not ready yet. It takes about 20 minutes. In those 20 minutes is when you can take a nap. So you take your nap. This is floating around the bloodstream. We'll just leave it out here because he's just waiting in the bloodstream for something to bind to. So floating in the bloodstream, adenosine is already bound to the receptor site. The receptor site, they have their little happy dance, makes you sleepy. Take that 20-minute nap. Within that 20-minute nap, your body goes through a process that will, like we talked about earlier, releases the adenosine into the bloodstream because now it's no longer as tired. So a bunch of these receptor sites open up. The caffeine can then go to work and bind to the receptor sites so that when you wake up in the 20 minutes, caffeine is in those spots. Your body still thinks it's tired, because probably is, the adenosine comes floating along through the bloodstream trying to bind to these receptor sites, but it can't because caffeine is hogging the space. So the adenosine just floats off into your bloodstream and gets metabolized like we talked about earlier. The key about the 15 to 20 minutes is that beyond a 20-minute nap, your body begins to enter REM and a deeper sleep. And as you try to emerge from a deeper sleep, you have a tendency to feel groggy. You have a tendency to feel like you've overslept. But this doesn't happen within those 20 minutes. So within the 20 minutes, it's enough to release the adenosine from the receptor sites. Caffeine can move in, bind to the receptor sites, and prevent any more adenosine from binding and making you feel sleepy. So you're left with a receptor site, happy to have some caffeine on it, and some poor sleepy adenosine just floating around, looking for a place to go. So does that make sense? So there you have my arts and crafts project for this evening, and a little bit of quasi-science, I guess, little how to explain it in layman's terms as to what the caffeine, adenosine, and receptor sites have to do with each other as it relates to a caffeine nap. Hope you enjoyed this video. Thank you very much and for watching, and maybe I'll be able to get back to sleep. I promise I didn't have any caffeine. None after like 2 o'clock today, and now it's almost 1 o'clock in the morning and I can't sleep. Lucky you. Bye-bye.